Hello everyone, welcome back to Solid Geometry series. So for the first four videos, we were talking about orthogonal relations between a line and a line, a line and a plane, and a plane and a plane. Today, we move on to another exciting topics, and that is intersections and collinearity. And with this, I have an exciting problem for you all. And here's the problem. Let S.ABCD be a pentahedron with quadrilateral base ABCD such that AD is not parallel to BC. Let M be a point on SB and O is where AC intersects BD. A. Find the point N where SC intersects plane ADM. And B. Prove that S, I, and O are collinear. Now I do realize that point I is not yet in the figure, but by the time we move on to part B, I will introduce point I. Okay. Feel free to pause the video if you want to give it a try. Otherwise, stay stunned for the solution. Part A. We need to find where SC intersects plane ADM. And according to the problem statement, this point will be called point N. This is for reference purposes only. You can call it whatever name you want, whether point X, point Y, point T, doesn't matter. But we need a name for it, and we'll call it point N. Okay. Then clearly you see that M is a point that lies on both planes, ADM and SBC. We will denote this result number 1. Note that AD is the common line of intersection between planes ADM and ABCD. Likewise, BC is the common line of intersection between plane SBC and plane ABCD. We call this result number 2. Since AD and BC both lie on plane ABCD, therefore they do intersect. We're going to go ahead and let them intersect at point E. Then by result number 2 above, we have E is the common point that lies on both planes ADM and SBC. We call this result number 3. Then from 1 and 3, we have ME is the common line of intersection between plane ADM and plane SBC. We call this result number 4. Note that in the figure, ME appears like the line of intersection between plane AEM and plane SBE. However, plane AEM is simply the extension of plane ADM, and plane SBE is simply the extension of plane SBC. Since ME and SC both lies on plane SBC, they do intersect. So we let N be the point where ME intersects SC. Thus, N is the point where SC intersects plane ADM. And that is it for part A. Moving on to part B. Let DM intersect AN at I. We need to prove that S, I, and O are collinear. In the context of solid geometry, how do you prove 3 points are collinear? You may have some experience with proving collinearity from classical plane geometry. But as it turns out, it is much simpler to prove collinearity in solid geometry. All we need to show is that those 3 points lie on the same common line of intersection between two different planes. And that's what we are going to do. We have O is where AC intersects BD, and I is where AN intersects DM. So clearly, OI is the common line of intersection between plane ACN and plane BDM. And we will call this result number 5. Furthermore, S is a point that lies on CN, and CN is part of the plane ACN. Likewise, S is a point that lies on BM, and BM is part of the plane BDM. So together, S is a common point that lies on both planes, ACN and BDM. And we call this result number 6. So from 5 and 6, we deduce that S lies on OI. And thus, S, I, and O are collinear. There's a minor typo that I just found out. In equation number 5 above, I should have used the equal sign instead of the subset sign. So it should be OI equal to plane ACN intersects plane BDM. Thank you. That is it for this problem. If you enjoyed this video, you can consider subscribing to my channel. There's a subscribe button down below that you can click on. In addition, consider giving this video a like, and together it will help bring this channel to a broader audience. Your thoughtful assistance will help this channel grow, and at the same time, it will give me the motivation and the momentum to do more and to complete this long series in solid geometry. That's it for today. Thank you for watching and have a good evening. Bye bye now.